Hello, thank you for joining me today. I'm Dean. Today we're going to be sticking to the topic of the sequence of operations, and we're going to be discussing the gas and electric furnace. Um, those are the units that are typically in most houses. Like I said in the other videos, you got your more sophisticated and upgraded systems like the geothermal and the radiant heat and so forth. But we're going to pretty much stick to the gas and electric, and I'm going to do videos on those other units, those specific units, because I might have to go in a little bit more detail. But today I'm going to do the basics of the sequence of operation, and that's how the unit is supposed to work. And that's going to tell you a lot of information about where you at and what kind of part needs to be replaced. And some of these parts you can actually clean and get the unit back and running, and we'll go over that. So the first step of the sequence of operation is the thermostat. The thermostat, its whole job is to control the unit. Now, you go to your thermostat and you cut it on. Let's say you're cold, you cut it up, and it clicks. And when it clicks, it sends power to your furnace control board, and we call that a call for heat. And when that thermostat sends power back to the control board, then your inducer motor cuts on. Now, the inducer motor is a little small fan that throws combustion gases out, the carbon monoxide. It throws combustion gases out of the house in the flue pipe up through the roof. And what that does is ensures that you don't have any of those gases coming inside of the house. This is a safety. So that's step two. Step three is the pressure switch closes. Now, as long as that flue pipe is clear, no bird nest, nothing, no blockage, no anything blocking it out, it's gonna send power to the pressure switch. That pressure switch is sensing the negative pressure. Now, let's just say that the flue pipe was clogged up, then the pressure switch won't close, and then it'll send a faulty signal back to your control board, and the unit won't light up. So the thermostat is one, the inducer motor is number two, and then your pressure switch is number three. Those are the three Those are the three sequences of operations, three levels. Now, going on to the fourth level is going to the igniter, and before it goes to the igniter, it checks all the limit switches. You know, like it's the limit switches to heat sensors. And what it does is it sends a signal, and if the signal comes back, then it goes ahead and it sends power to your igniter, which glows. And once it glows, in the last final stage of a gas furnace sequence of operation, is going to be the fire lights up. Once the fire lights up, then once the fire lights up, then the flame sensor is going to sense that flame. It's going to sense the flame, and once it senses that flame, and it's going to send a signal back to the board letting it know that the unit is actually lit and everything is going good, then the blower motor is going to cut on. So once that blower motor cuts on, it starts conditioning heat. It starts conditioning the air, producing heat and blowing, and your return is sucking the air, and your supply is pushing the air. Now, that's the complete sequence of operation on a gas furnace. Now, throughout, as long as that's going, you have limit switches constantly taking temperatures, reading temperatures, and making sure that the unit is operating at the operational temperatures. If one of those units limit switches becomes hotter than what it actually should be, it's going to cut the unit off, and it's going to blink a code. Let's say, for instance, like we say, that's why it's so important for you to change your filter, because if you don't change your filter and the filter is dirty, then the air coming into your unit can't blow as efficient as it should. So now the unit builds up heat. And when it builds up heat, the limit switches will actually cut the unit off, and it'll cool off for a while, and then it'll cut back on. And it'll keep going through this cycle until that limit switch ended up, defaulting. And now you got to get a limit switch replaced. And it was the only cause of a dirty filter. So that's why changing your filter is very, 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 very important, especially in heating, because you're dealing with a lot of heat. You know, that's the sequence of operation with the gas furnace. Now, let's say your unit called for heat, inducer motor cuts on, and that's the last stage. It's gonna blink a code letting you know what happened. Something's wrong with the pressure switch, or something's wrong with one of your limit switches. There's something wrong with one of those switches that won't let it light up. Or let's just say that the unit did light up and it shut off instantly. That's letting you know that the flame sensor is dirty. You can actually take the door off to the unit, make sure that there's no power to the unit, and if you can cut it off, cut the power off. I'm talking about the main power to the furnace. Not going to the thermostat, cutting it off. I'm saying going to your breaker box and cutting off furnace. And take the flame sensor off, and get you a wire or something to clean it off, SOS pad or something brittle, something to clean that off with, and stick it back in there and give it another shot. That's typically something that happens. A lot of dust and particles get on those flame sensors throughout the winter, so throughout the summer from not running in the winter. Okay, so that pretty much rounds it up for the gas furnaces. Now, going on to the electric unit, the sequence of operation is a little bit more simple because it's not as many components, but it still has the same similarities. And the number one is the thermostat cuts the unit on. We call that a call for heat. And in electric air handlers and electric units do not have flue pipes because there is no combustion going on inside of the unit. There's no gases. So it doesn't require a flue pipe. So they have more switches and limit switches because it's using electricity to create heat. And the way it's doing that is resistance. And you got your electric 220 volts coming inside of the unit, and the heat strips actually slow them down through resistors, and that creates heat with amperage. That's why it's a little expensive to run electric units, because you're using amperage. You're using electricity. And so it uses that electricity, it slows it down, and it creates heat, and your fan cuts on, and it blows it and cools it, tries to cool it. So that's creating heat. So you got your thermostat is one, and then your heat strips cut on, and your fan cuts on, and then it blows the heat. Now, as it's blowing heat, it's constantly checking limit switches, making sure everything is working within temperature range that it should. Electric units is another, just as any other unit. Changing that filter is very, very important, because if those limit switches, the air is the return air, which is the room temperature, which is cool air, is actually cooling that unit off. If that filter is clogged up, then it's not going to cool off properly, and you're going to be having excessive heat inside of that unit. And that's just, a lot of amperage being used that doesn't need to be used, and there's a lot of voltage. Instead of heating the house, it's heating the air handler, and we want all of that heat in the air so that unit could run and hurry up and cut off and save you money. So electric air handlers are a little bit more simpler, but it's just as much as it's just as important to just to make sure you're watching everything, and it doesn't have a flame sensor or none of that, because all it has is electric heat strips and safety switches. So that pretty much wraps up the sequence of operation. One more thing is, well, I'm gonna do another video on blower motors, because I was gonna get into the how the unit capacitors, when they need capacitors, or when how units are running the blower motors, and you need to know about that when it comes to the sequence of operation, because you can understand what level and what's supposed to be happening when. That's very, very important. So I'll do a video here and on fan motors, on blower motors, on how when they're supposed to cut on, and how they're supposed to operate, and what you can do to help that fan as much as possible, because each part in these units are expensive, all the way to the door, to the furnace, to all of these units, all of these parts are very important. Not one manufacturer ever put a part on the unit and it's not that important. It's not for show and tell, but it's for safety, and it's for the efficiency, and it's for the value of the unit. So thank you for watching. I'll be putting up plenty more videos, and you continue to stay warm in the winter and cool in the summer. Thank you.